Alright, now, when we graph two relationships, let's think about talking on the cell phone versus grades. The more you talk on the cell phone, what happens to your grades?
They get worse.
They get worse. So, is it the cell phone talk that changes the grades, or is it the grades that changes the cell phone talk?
The cell phone talk changes the grades.
So, we put on the bottom the thing that does the changing, and on the side we put the thing that is changed. So we would put the amount of cell phone talking, and over here we would put grades. Now, I have a question. The more you talk on the cell phone, you said the more you talk on your cell phone, the worse your grades are. So is my line going to be like this, or is my line going to be like that? Don't answer right off the bat. Don't answer right off the bat. Look at it for a second. Is my line going to be this way or this way?
This is what you're changing, so it goes grades go down, and cell phone talk go up.
So it's going to look like this. Okay? Cell phone talk went up, grades went down. Now think about it for a second. Cell phone talk went up, the other thing went down. Is that a direct relationship or an indirect relationship? Indirect. Good. And sometimes we call that inverse. Okay? So if it's an inverse or indirect, the graph is going to look like that. If it's direct, the graph is going to look like that. Okay? So let's think about our dry ice inside the balloon that has now expanded our balloon. First of all, let's think about temperature and the energy of the particles. Okay? So is the temperature changing the energy of the particles? Or is the energy of the particle changing the temperatures? The temperature is changing the energy of the particles. Okay? So, what goes on the bottom? Temperature or energy? What's doing the changing? Temperature. So that goes on the bottom. So temperature goes on the bottom. And energy of the particles goes here. Now, think to yourself. Don't blurt out the answer. Just kind of think for a second. And just ring. Focus. As the temperature goes up, what's happening to the energy of the particles? Is it going up or down? It's increasing. Because when it warmed up to room temperature, those things move more and they spread out, right? Okay? So, as the temperature goes up, the energy of the particles goes up. So is that a direct relationship or is that an indirect relationship? One went up and the other one went up. That's direct. So is the graph going to look like this or this? Top one or the bottom? Top one. Good. So that's what that graph's going to look like. Okay? Let's also think about temperature and volume. As the CO2 warmed up, what happened to the volume of the CO2? It increased. So the temperature increased, the volume increased. Is that indirect or direct? Direct. So, what's the graph going to look like? Draw it real quick. Just sketch it. There you go. What goes on the bottom? Temperature or volume?
Temperature.
Correct. And what's it changing? The volume. Okay. Now, let's think about temperature and density. Don't answer. Just think before you blurt out an answer, okay, Cassandra? Now, if the temperature increases, what happened to the density of our dry ice?
The temperature increased.
Did the density increase or decrease? Now, shh. Shh. Remember what density is. Density is how close things are. The higher the density, the closer they are. The lower the density, the more spread out they are. So as the temperature of our dry ice increased, what happened to the density of the dry ice? Did it get higher or lower?
Lower.
It got lower. So temperature went up, density went down. Is that direct or indirect? Indirect. Which one goes on the bottom? Temperature, because it's doing the changing. It's changing the density. So what's the graph going to look like if it's indirect? good. So, to rehash, I'm going to go back and forth. I'm going to ask each of you individual questions, and you simply answer the question as best as you can. If you get it wrong, that's okay. We're going for speed. Solid to liquid is called what? Melting. That's all I'm looking for. Liquid to gas is called what?
Evaporation.
Gas to liquid is called what?
Gas to liquid is called condensation.
Good. And liquid to solid is called freezing. When you go from a solid to a liquid, does the temperature increase or decrease? When you go from a liquid to a gas, does the temperature increase or decrease? When you go from a solid to a liquid, does the density increase or decrease?
Decrease.
Very good. When you go, and this is, I'm kind of going out of order here, when you go from a gas to a liquid, if I take this gas and I turn it into a liquid and then into a solid, does the density increase or decrease?
Increase.
It increases. Because the particles do what?
They come together.
They come together and get closer together. Okay? So, we've learned about phase changes, and we've learned how to graph two variables on a graph and sketch whether it's direct or it's indirect. Okay? Now, the part that you've both been waiting for,
Pop the balloon.
you can pop the balloon if you want to.
I need that now.